Hello, and welcome to this lesson in discrete structures, or maybe quantitative reasoning is the class you're in if you're watching this. I'm going to do an application problem with three sets using a Venn diagram. This is probably one of the harder things students find in the sets and Venn diagram topics. So this is kind of a classic problem, and the trick is in how you read the problem and knowing where to start. So in this problem, 80 students respond to a survey about classes they are taking. They respond as follows. So when they respond, they check off the types of course they're taking. There's a form, check if you're taking math, check if you're taking English, check if you're taking science. If you're not taking any of them, you turn it in blank. Let's pretend it's that way. That might help you understand the context a little. So there were 80 students who responded, and some of them responded maybe without having anything checked off. So you see that 35 of the forms have math checked. 40 of the forms have English checked, 10 have science checked. And then we've already counted these, but 8 of those in English or science were actually in both. So 40 people checked it off, 8 people in English also checked off science. So there's 32 in English who did not check off science. That's how you have to read that. So this is like the totals, and here within those totals, 8 of them were in English and science, 20 were in English and math, and 4 who were in math and science. And there were actually 2 students who were in all 3 courses. So the question is, how many were taking just math? That gets really convoluted here. We're going to have to look at this, and you look at it backwards. First, I want to show you this Venn diagram. And I'm going to set up the Venn diagram where this is math, this set is English, and this set is science. Now, I'm going to label the regions. 1, 2, and if I label them with Roman, 1, 2, 3, 4, 5, 6, 7, and outside of all the circles is region 8. So if I want to know the students just taking math, that'll be in region 1. How many students are taking just science? That'll be in region 7. And how many not taking any of these 3? That'll be in region 8. They're outside all 3. But let's look a little closer. How many are taking math and English? That's an intersection question. The and is an intersection. That is in regions, as I've numbered them. Now, students get very confused here. They think it's just region 2. It's actually region 2 and 5. Together. Math and English and science, all 3 together, is just region 5. So if you fill in region 5 first, and then you go to fill in region 2, the people, you've already counted some of the people who are taking math and English. They show up in the people who are taking all 3. The intersection of math with science will be regions 4 and 5 together. This whole thing here, if you look at these circles, if I shade in there, I'm in both math and science. Some of me is also in English, but that doesn't matter. The part that's in both in math and science is these 2 regions right here. So I'm going to try to erase that without creating mayhem. Oh, that's nice. So you get the regions containing 2 of the sets are still that same egg shape. They still get that same egg shape as if you just had a 2-set Venn diagram, and your intersection of the 2 sets is this region here, this egg shape. All of your intersections between 2 sets are egg-shaped. What gets confusing is when we start talking about, well, first of all, I want to erase that. When we start talking about the regions, so now this is only 5 is the region with all 3. But if you're in math, English, and science, it's also true that you're in math and English, and it's also true that you're in math and science, and it's also true that you're in English and science. So when you're talking about 3 sets, it's just this thing. When you talk about 2, you don't just take this top one. You have to take the whole thing together. The whole thing together. The whole thing together. The oval shape is always the intersection of the 2 sets. So the last one I have to do is English overlapping science. That would be this circle overlapping this circle. That will be regions 5 and 6. So that's one thing I want to get clear. If that's not clear, then the rest of this will make no sense at all. All right, I'm going to erase the region numbers. And maybe, so they went across 1, 2, 3, 4, 5, 6, 7 in region 8 was out here. Instead of filling in with the region number, I'm going to fill in with how many. So the first question is how many students are just taking math? You kind of can't answer any of these questions until you set it up to answer them all. And how am I going to do that? Well, I'm going to start with finding the number of students who were in this intersection of all three. And then I can back my way out to the rest of it. So there are 2 students in all three. There's my 2. 2 students in all three. Then the 2 plus however many I put here will be however the number that are in math and English. So 20 are in math and English. So I need this section plus this section to add up to 20. So that gives me an 18 there. So I do the same thing working my way over here. In this region here, I see them in the English and the science section, English and science. So I look to see how many are in English and science, and there's 8. So English and science would be these 2 regions here combined. The total has to be 8. So I write a 6 there. 6 and 2 is 8. And then the last one I have is right here. This is math and science. This bottom circle is science. So math and science, there'll be this 2 plus this. So math and science for this amount here has to add up to 4. There are 4 in math and science. So that 2 plus that 2. Now this 2 plus this 2, that's how many are in both math and science. So let me remove some of my writings. I kind of like the way it does this. All right, so that's how many belong to those. Now, let's look at the total number of students in each class now. So if I look at, and I'm going to try to pick a different color here. If I look at just how many total in math, 35 total in math. So I have to have 35 in the circle, but I already have 18. I already have 2. I already have another 2. So I have to do 35 minus this 18, minus this 2, minus this 2. That'll tell me how many are just in math. And when I write that number down, I see it's a 13. So if I had 13 plus 18 plus 2, I should get this 35. So I can answer this question now. There are 13 who are just taking math. Now, how many are just taking English? I didn't ask that question, but I can fill that in. So I have a total of 40 in English. So this is going to be 40 minus the 18 minus the 2 minus the 6. I subtract all the ones I've already accounted for, and that looks like that should be 14. That's 18, 2 is 20, 26. 40 minus 26 is 14. Okay, so there's 14 in just English. And then for just science, it says 8. It says 10 are taking science. So in this circle for science, this big circle here, those numbers have to add up to 10. So I have to figure out what's missing here. It turns out 6 plus 2 is 4. 6 plus 2 is 8, plus 2 is 10. I already have 10, so there's nobody just taking science. So let's see if I can answer any of these questions now. And we were talking about regions here. I don't want you to pay attention to that right now. How many students are just taking science? That's 0. How many students are not taking any? Oh, what do you mean not taking any? Well, you have to look. 80 students answer the survey. Do my numbers add up to 80? I have 13 plus 18, region 1, region 2, region 3, plus region 4, plus region 5, plus region 6, plus region 7. These numbers add up to 55. 6 and 2 is 8, and 2 is 10, 14 is 24, and 18 would be 42, and 13 would be 55. There's only 55 students accounted for in these circles. I had 80 students total. So 80 minus 55 gives me 25. So what I do with all of that information is in my universal set here, somewhere outside of these circles, I write the number 25. These 25 students sitting outside of the math, English, and science circles are the ones who weren't taking any of those. They might have been taking a psychology class or a history class or art class, but they weren't taking math, English, or science. That is how you approach these problems. You always start with who are in all three, then look at how many you have to make up, how many you have left to be in 2 of the 3 in each of the sections, and then how many you have to make up to have the total number of math right, the total number of English right, the total number of science right. And then once you get that, you add that, and the difference between that and the total number of students are the ones who were outside of those 3 sets. So that students find that difficult. I actually find those kind of fun once I figured out how to do them. You can email me your questions, and I'll see you in class.